Lesson number 3, the general form of an equation. So what we looked at in lesson 1 and in lesson 2 was what we called the slope y-intercept form of a linear equation. Y equals mx plus b. M was the slope, b was the y-intercept. What we look at now is the general form of the equation of a line. So the difference between this form and this form is what? What have I done from here to here?
It's an equal y equals 0.
Yeah. Well, the y is here. So really, all I've done is I've taken the y and I've moved it onto the same side of the equation as the x and the b. Instead, we don't call this m because it's no longer the slope, and this is no longer the y-intercept. So we have to be careful, and this is no longer a slope y-intercept form. These numbers here do not necessarily correspond to things that we can accurately or easily see on the graph. So we call this the general form of an equation. Any equation that is equal to 0 is called the general form of that equation. So next year when we look at quadratics, there will be a general quadratic equation. If you were to look at cubic functions, there's a general form of a cubic equation, and so on. So the general form of an equation, everything is on one side of the equation. It equals 0. A, B, and C are integers if possible. We try not to use real numbers. We try not to use decimals. We try not to use fractions. And A we usually express as a positive number. The purpose of the general form is it does allow us to draw horizontal lines, vertical lines, and oblique lines, which are those diagonal lines. So if we look at class example number 1, y equals 5x minus 8. If I wanted to write this in general form, I move the y over to the other side. So if I move the y over to the other side, how do I move it to the other side? Would I divide by y? Because I would have to subtract by y. So I would subtract by y on both sides. So there's my 0. And then I'd have a 5x, a negative y, and a negative 8. So if I think in terms of my algebra tiles, remember I showed you before an x tile and a y tile are just different lengths or sometimes different colors. Okay? If I look at B, I have a fraction. So what I want to do is I want to get rid of that fraction. To get rid of the fraction, multiply by the denominator. So the denominator in this case is 3. I'm going to multiply everything by 3. So I take the y and I multiply it by 3. When I take 2/3 and I multiply it by 3, what do I get?
Would be 3.
Nope.
Or 1.
Nope.
No, 2.
It would be 2. The 3 cancels the 3 on the bottom. So I would get 2x and then 21. So the understanding why I would multiply the 2/3 by 3 is because then I get a 2. Why do I have to multiply the other 2 terms by 3?
Times 3 is on the outside of brackets.
And why did I have to put it on the outside of the brackets? Why couldn't I have just taken the 2/3, multiplied it by 3, and called it good? What is this? This is an equation, which means it's sitting on a balanced scale. So if I multiply something by 3, am I changing the value of my balance scale? Yes. But if I multiply everything by 3, I do the same thing to every term. Am I changing it? No. It's kind of like taking a recipe and doubling all the ingredients in the recipe. If you double all the ingredients in the recipe, do you change the outcome of the recipe? Generally, there are some exceptions, but generally you don't. But if I double the flour and I don't double the butter, Is that going to cause me problems? Yes. So an equation's the same way. Okay? So now when I look at C, I have two fractions. I have quarters and I have fifths. So what number could I multiply to cancel out the quarters and the fifths? So think of what would be a common multiple for 4 and 5. 20. So if I multiplied everything by 20, hopefully that'll get rid of my fractions. So I get the 20y. What is negative 1/4 times 20? Positive or negative? Would be a negative 5x. And then 3/5 times 20? Okay. So before we grab our calculators to help us do this, what's 20 divided by 4? 5 times negative 1? Negative 5. 20 divided by 5?
4.
4. And 4 times 3 is? 12. So in this case, the other thing to remember, so what did we say A, B, and C had to be? We wanted them to be integers if we could. So positive, whole numbers, positive or negative whole numbers. And what did we want for A? We wanted A to be positive. Is A positive here? Multiply everything by negative 1, or I can just move it to the other side of the equation. Because how would I get rid of the negative 5x?
Why don't you want everything on one side of the equation equal to 0?
Well, what happens if, how do I get rid of a negative 5x? What does this equal now? What's negative 5x's plus 5x's? 0. As long as I do the same thing to the other side, it's balanced, right? How do I get rid of positive 12? Negative 12. So negative 12. What am I left with over here? 0. I don't have anything over here because I pushed it all to the other side. I have a 5x, a 20y, and a negative 12. So when I go over the equal sign, if I take negative 5x and I put it over here, what does it become? Positive 5x. If I take positive 12 and I move it over here, it becomes negative 12. Oh, we didn't actually finish this one. If I take the 3y and I move it over here, what will it become? Negative 3y. So 2x, negative 3y, 21. If I moved everything over onto the left-hand side, my 2x would become negative. My negative 3y would become positive. My 21 would become negative. Okay, so it doesn't necessarily have to equal 0, doesn't always have to be on the right side of the equation. It can be on the left. What's important is my x still remains positive. And here's another question. Is this the same as that? Yeah. When it equals 0, the equation can actually be on either side. Okay? So let's give you some practice. Question number 1, B, D, and F. So let's move on to the next part. If I give you the equation of a line in general form, we can determine the slope and the y-intercept by converting it into a y equals mx plus b form. So basically what I'm going to do is I'm going to isolate the y, or I'm going to get the y by itself. That's what it means to isolate. So if I look at 2x minus 5y plus 25, so if you do that, I lost my train of thought. I want to isolate for y. There we go. That's what my train was. I want to get y by itself, so I've got this negative 5y. And if we remember what we were doing above, if I move something across the equal sign, the sign changes. So if it's negative on this side, it will be positive. So if it's positive on the other side, that's what I want. I want my y to be positive. And then what do I do? Pardon? So how do I get y completely alone? Divide by 5. So I take the 2 and I divide it by 5. Take the 25 and divide it by, or sorry, x, yes. If I take the 25 and divide it by 5, what do I get? And if I take the 5y and divide it by y? Okay? So now if I look at b, in this case here, the y is already positive. So it's the other things that I want to move to the other side of the equation. So the 2y is positive. So I move this 6x over, it would become negative. Move the 15 over, it will become positive. And then I want to divide everything by 2. So if I take negative 6 and divide it by 2, I get? Negative what?
3x.
Negative 3x. And then if I take the 15 and divide it by 2, I don't get a whole number, so I'm just going to leave it as a fraction. Okay, so now that we have these in the slope y-intercept form, we can go back and identify. What's the slope of my first line? Pardon? 2. And what's the y-intercept? In the second equation, what's the slope? Negative 3. It's not the x, it's just the... And then what's the y-intercept? 15 over 2. Okay. The lines 3x minus 4y plus 8 equals 0. Actually, maybe I'll give you a couple of questions to work on again. Question number 3. Yeah. So question number 3 is kind of like question number, or like this one. The only difference is it asks you to calculate the x-intercept as well. So to calculate the x-intercept, what do I know? When the graph crosses the x-axis, what do I know about the y-coordinate?
0.
Y-coordinate equals 0. So if I start with my general equation, let this equal 0, and it disappears. I now have 2x plus 25 to solve. Okay? So I'll give you about 5 minutes to do that. Okay. These two lines have the same y-intercept. Determine the value of k. So let's find out what the y-intercept is of this line. How do I find the y-intercept? So think, when the graph crosses the y-axis, what do I know about y or x? X is equal to 0. So I let x equal 0. So 3 times 0 minus 4y plus 8 equals 0. Well, 3 times 0 is 0. This negative 4y, if I put it to the other side of the equation, would become a positive 4y. So I get 8 equals 4y. And what would y equal? 2. So now when I go into the next equation, that means that if I put 2 into this equation and 0 in for x, because if it's the same y-intercept, x can equal 0, and y is going to equal 2 because the y-intercept is 2. So 5 times 0 minus k times 2 minus 6 equals 0. So 5 times 0 is gone. Negative k times 2 is negative 2k.
2K.
Which, if it's negative and I put it to the other side of the equation, would make it positive. So let's put it to the other side of the equation. And then is negative 6. Divide both sides by 2. K equals, without yawning?
Negative 3.
Negative 3. Okay. So in the next question, which of the following lines are perpendicular to the line 4x minus 2y plus 9? So what do I need to know? Slope. So I start off with my 4x minus 2y plus 9. I need to find the slope of this line. So to find the slope of the line, I have to isolate y. I have to get y by itself. Y is negative, so I'm going to start by moving it to the other side. 4x plus 9 will equal 2y. And then I'm going to divide everything by,
2.
so what's 4 divided by 2?
2.
And 9 divided by 2 would become 9 halves. And 2 divided by 2 would be 1. Okay?
The slope is 2.
So the slope of this line is 2. So what would the perpendicular slope have to be? Negative 1 half. Because it has to be the reciprocal. So 2 is the same as 2 over 1. Reciprocal becomes 1 half, and then the opposite side. So I'm going to give you a couple of minutes, and what I want you to do is I want you to figure out the slopes of the next 3 equations. So which of the following lines are perpendicular? So we solve for the slope in each of these. So for the first one, I have a negative 6x plus 1 if I move those over, divided by 3, and I would get negative 6 divided by 3 is negative 2x plus 1/3. Is this perpendicular? No. Okay. For the next one, the 2y is positive, so I'm going to keep it on this side. Move the x over, which would make it negative, and move the 12 over, which would make it positive. Then I would have to divide everything by 2. So there's my negative 1 half x, because this is a 1x. It's a negative 1. Plus 6. Is this perpendicular? Yes. Okay. And then the last one, put the 5y to the other side, which would make it a negative 5x. 5x to the other side. Divide by 10. And I get negative 5x over 10, which is a negative 1 half x. Is this perpendicular? Yes. Okay, so now if we look at class example number 5. Write the equation of a line that is perpendicular to one line and has the same y-intercept as the other. So if it is perpendicular to 2x plus 5y minus 7, what do I need to know about that line? The slope. So I need to isolate for y. So I'm going to rewrite it as 5y is negative 2x plus 7, because I move those two things to the other side. And then divide by 5. So what is the slope of my perpendicular line going to be? 5 over 2. Okay? So then the next part is I need to have the same y y-intercept has this line. So how do I find the y-intercept? Let x be equal to 0. So 2 times 0 plus y minus 6. 2 times 0 is 0, so that's gone. Y is positive, so I'm going to leave it on this side and move the negative 6 to the other side. And I get y equals 6. So my y-intercept is equal to 6. Now I'm asked to answer or to find the equation of this line that's perpendicular and has this y-intercept. So that's my y equals mx plus b. What's m in this line? 5 over 2. And what's b? So this is the equation of the line in slope y-intercept form. If I want to make this into general form, what would I need to do? I need to get rid of the fraction first. So how do I get rid of the fraction? Say that louder, Kate. Multiply everything by 2. So 2 times y. What's 2 times 5 halves? So I get 5x plus 12. And then I need to move everything over onto one side of the equation. The question is, do I move the 2y or do I move the other stuff? Why do I move the 2y? Because 5x is positive. So what happens to the 2y when I move it over? Comes a negative. So there's my general equation. And here is my slope y-intercept equation. Okay? A student made the following statements about a line with an equation 2y equals 5x plus 12. The line has a slope of 5. Well, what do I need to do in order to figure that out? And how do I find the slope? I divide everything by 2, and what would y? So I'd get y equals what? 5 halves x plus 6. Okay. So does this line have a slope of 5? No. Nope. Is this line parallel to the next line there? So how do I figure that one out?
That's the same slope.
So in order to find that out, what would I want to do? Move the y over, so 10x plus 13 equals 4y. Divide by 4, so 10 divided by 4, 13 divided by 4.
But you can divide by 2.
So 10 over 4 can be reduced by dividing by 2. 10 divided by 2 is?
5 over 2.
5 over 2. So is that true? Yeah. Okay. And statement number 3, the line passes through the point -2 and 1. What that means is if I put those numbers into the equation would then be true. So for y, I put in a 1, and for x, I put in a -2. So what's 2 times 1? 5 times -2? And does 2 equal 2? Yes. So this statement is true.
2 does equal 2.
So 2 does equal 2 in this case. Okay, so the questions, I gave you questions 1 and 3 so far. Questions 4 and 5, and then 8 to 16.
4 and 5.
Yep.